Hi class. So here we are on lesson 10.3 and we're looking at the last half. So this is lesson 10.3 part 2. It's the last page of your notes, so I want you to find that page 6. This is all page 6. It's hard to write there up at the top, but your homework tonight is to watch this video and complete all the problems on your page 6. And then you're going to take a picture of the page 6 notes, not all the notes, just page 6. And you need to email me the picture of these notes that are completed by Wednesday before Zoom. Okay, so that's your goal here. So write down the notes, follow along, and complete the notes here with me. All right, so these problems are a little bit different than the ones we did in class because they have these binomials. Now, a binomial means two terms. So we have a two-term expression times another two-term expression. And we learned how to multiply those a long time ago. If we have, a plus b times c plus, you don't have to write this part down, but we FOILed this. F-O-I-L. The first one is a times c. Second one is plus a times d. The inner multiply is b times c, and the last multiply is b times d. And happens they're all pluses, but the thing to notice is we have to do 4 multiplies. Okay, so all of these problems are binomials. All of them have 4 multiplies. Now they're slightly bit more involved because all of them have radicals also. And so we'll get 4 multiplications with radicals, and then we'll be simplifying the radicals. All right, now depending on the numbers, big or small, sometimes you can multiply the radicals and know the answer, and sometimes you can't. It's not quite as obvious. The problems I picked here are somewhat reasonable here, so I'm going to rely on the perfect squares. So let's start the distributive law. On the very first problem, we distribute square root of 3 times square root of 3, and we're going to take the square root of 3 times the whole number 2. And what that gives us is the square root of 3 times the square root of 3. And then the second multiplication was a whole number 2 times the square root of 3, and that's not 6. You can't multiply and get 6 because the 2 was a whole number and the root 3 was a radical. That's half of our distribution. Now we've got to take 8 times the first one, 8 times the last one. Now again, we cannot go 8 times 3. So we will get 8 times the square root of 3. We can't multiply because the 8 is a whole number and the 3 is a radical. But on the last one, we have 8 times 2. 8 is a whole number, 2 is a whole number, so we can do that, and we get 16. Okay, I'll move the screen a little bit here. And so 8 times 2 is 16. So 4 multiplications. Now, notice on this one I didn't multiply it. And when they get bigger numbers, it's nice to have, instead of actually multiplying, it's nice to factor them and leave the factors. Now if you see a 3 times a 3, that means you've got 3. Okay, stop doing that. It means you've got 3 to the second power. And the square root of a second power is going to come out nice. So that first one actually has a nice answer. We get 3. So 3 times 3 is 3 squared. Square root of 3 squared is just a whole number 3, no square root. Now, then the next term, 2 squared root of 3, I haven't been able to do anything with that. Because the 2 is a whole number and the 3 is a radical number, I can't multiply. And then I get 8 square root of 3. That one's kind of stuck too. And then I have a 16. Now, that's the FOIL method worked out as much as we can do. However, can we simplify? Well, we can simplify because I want you to notice that 3 is a whole number and 16 is a whole number. Those are like 3 cherries and 16 cherries. And then I have square root of 3 and square root of 3. Those are like pairs. I have 2 root 3 plus 8 root 3 is like 2 pairs plus 8 pairs. Those are like terms. So some of these I can combine. The 3 plus the 16 makes 19. And the 2 root 3 plus the 8 root 3 makes 10 root 3. That is the multiplied answer and the simplified answer all done. So we first had to FOIL 4 multiplies, and then we started simplifying terms and combining like terms, and here we got the simplify. Well done. Okay, now the second problem at the top, I want you to notice it's a very unique problem. These are called conjugates. Now, you don't have to know the name of them at this stage in our algebra experience, but conjugates always multiply in a very cool way. We get a great outcome with conjugates. It goes back to our polynomial days when we multiplied a plus b times a minus b. We actually learned a formula, a squared minus b squared. Now you don't have to do the formula. You can do it the long way and go a times a is a squared. Then you get a minus ab. And then you get a plus ab. And then you get a b times a negative b is minus b squared. And it's always going to happen that the middle terms zero out. They're opposites and they're going to cancel. And the only thing you're left with is a squared minus b squared. Now why is this a big deal? Because they're second powers. And second powers always cancel square roots. So when you have these conjugates, these a plus b times a minus b, nice things are going to happen because all the square roots are going to get a second power on them, and those second powers will make the square roots go away. And so multiplying conjugates always come out to a nice answer in the end. Now, the first one wasn't conjugates. They were both pluses, and they had different terms in them. But this second one, they both have a square root of 7, and they both have a 4. One's a plus 4, one's a minus 4. That's a perfect setup for the conjugate. So let's work this together and see how it simplifies. Get rid of all my scratch work there, and we'll just FOIL. Now, I know you guys are kind of new with the radicals, and so mixing up the polynomial formulas and the radicals may be weird. So I'm not going to do the formula. I'll just do the regular FOIL method. Take the first term times the first term. And that's the square root of 49. And if you're good with that, write down the square root of 49. But when they get bigger, sometimes it's nice just to say 7 times 7. Square root of 7 times square root of 7 is 7 times 7. Now we'll multiply the next one. We have a square root of 7 times negative 4. Oh, that's negative 4 root 7. Now we're going to do the inside multiply. Positive 4 times root 7. And then we'll do the last one. Positive 4 times negative 4 is minus 16. Okay, now what's going to happen to these two in the middle? Now that's a very unusual specific setup on this problem. I have a negative 4 root 7, a positive 4 root 7. They are like terms, and one's positive, one's negative. They're going to go to 0. It's all canceled out. Now, on the first multiply, if you elected to just say, oh, square root of 7 times square root of 7 is 40, square root of 49, that is a perfect answer. But if you elect to do this other way, now I suggest you watch the YouTube videos, because there's like 3 or 4 of them that are really good to help you understand how to do these numbers. The numbers can be done with their exponents instead of memorizing, the 25, 36, 49, 64. You can memorize and work all the perfect square numbers, but you can also do them by exponents, and then you don't have to use that. You have to factor still, but it might be helpful to you to watch those videos. And that's what I'm doing here, is I'm using the video method of factoring. And I see, 7 times 7. That's 7 to the second power. That's 2 factors of 7, 7 to the second power. And the square root will cancel a second power. So square root of 7 squared is just the whole number 7. No square root, just the whole number 7 minus 16. And what happened? All of the radicals are gone. We just have a whole number. Minus 7 minus 16 equals negative 9. There is our simplified answer. Okay, now, we did the one like this in class, but I know I did it really fast. I'm going to do it again here just for the sake of completing the notes. Okay, so first multiply. Hey, wait, look. This is A and A. They're the same. And it's B and B. It's the same. One's a plus, one's a minus. This is that conjugate thing. It's going to multiply out really nice. But let's watch it all unfold. And I think I liked how I did it before. I'm going to multiply the first multiplication as the red distribution. So the first one is 5 root 3 times 5 root 3. That equals 5 times 5 is 25. I can multiply the 5s and the 5s because they're whole numbers. And I can multiply the root 3 times the root 3. Then I have a minus. And the second multiplication, I just finished that one. That one's done. Now, the second one I have to do is 5 root 3 times the 6. Now, there's a 6 in there and a 3 in there. I can't multiply the 3 times 6 because 6 is a whole number, 3 is a radical. But 5 is a whole number and 6 is a whole number. I can multiply those two and I get 30 root 3. Now, I'm going to run out of space on this. Sorry. You have plenty of space on your notes, but I don't. So I'm going to put my work underneath. Okay, that's half of the distribution. Now I'm going to do the inside. 6 times 5 root 3, but this is a positive 6 times a positive 5, which is plus 30 root 3. And then I have the last distribution, 6 times negative 6, which is a minus 36. And there it happened. That's all 4 multiplications, but 2 of them are opposites. And these 2 are going to cancel to 0. So the only thing left is these first and the last terms. Now, the 25, I'm going to put a bar under here just because my work is all scrunched. And this one is 25. Now, what is the square root of? This is 3 squared. In my head, I'm thinking 3 times 3 is 3 squared, and the square root of 3 squared is just the whole number 3. It became a whole number. So square root of 3 times square root of 3 is square root of 3 squared. That's nice. It's just 3. 25 times 3. And then I have this number left over, minus 36. So 25 times 3 is 75 minus 36, which equals a regular whole number 39, no radical. There we go. So that is the simplified, the multiplied and simplified answer of the second one. Okay, now, because I'm on Zoom here and I have, I'm on YouTube, I have a constricted space to work. You have plenty of space on your notes to do the last 2 problems below. I'm going to squeeze them in here and show my work going upwards. I hope that makes sense. So, now, temptation to avoid. It is not second power on both. This is not the distributive law. I cannot do that. I can't distribute on this because it's a power. And the power means I have to take the whole group, 7 plus square root of 5, times the whole group, 7 plus the square root of 5. That's what the second power means, group times group. Now, unlike the previous 2, they both have A and A. They both have B and B, but they're both plus. They're not opposites. They're both pluses. So this doesn't fit into that conjugate thing. The middle will not go to 0. So the last two in the yellow boxes, we had a positive and negative. They canceled out. These are both pluses. They're not canceling out. So we have to be a little extra careful as we do the FOIL method here. All right, so let's start. I'm going to do the red distribution. 7 times 7, 49. 7 times root 5. I can't go 7 times 5 and get 35 because the square root of 5 is a radical. So all I can do is say 7 root 5. Okay, that's half of the distribution done. Now I'm going to distribute the last two. Root 5 times 5, root 5 times root 5. Now root 5 times 7, be careful here, it's positive times a positive, which is a positive 7 root 5. And then a root 5 times root 5, I mean, you can say square root of 25. That has a nice answer. Or you can say root 5. My computer glitched and I fixed it here. Root 5 times root 5, that last term, is 5 squared. It's the square root of 5 squared. That's going to have a nice outcome. Now, the 2 in the middle, be careful. This is positive. This is positive. Now, they are like. We can combine these, but we combine them by adding the coefficient numbers. Okay, so now the 49 is still 49, and the middle ones is a 7 root 5 plus a 7 root 5, which is 14 root 5. It's like apples plus 7 apples plus 7 apples is 14 apples. And then the last one is a 5 squared. A square root of 5 squared comes out with a nice answer. It's a whole number, 5. I don't have a square root anymore. Because the square root and the second power cancel out, I'm left with just a whole number 5. Now, one more good thing on that is I have a whole number 5, whole number 49. I can combine like terms. So those two whole numbers will add up, and I will get 49 plus 5 is 54 plus 14 square root of 5. That is my simplified answer. All right, so it was just the FOIL method and just being careful with signs and adding like terms and simplifying radicals. So there's just a lot of parts, but every little part is something easy that we've learned already. Okay, one last example. I'm going to actually, that didn't work too well. I'm going to move this up and show my work below. You've got plenty of space on your paper to do that. And so here we go. It's a binomial times a binomial. This one has coefficients on the radicals, and the radicals have variables. Okay, but let's do the distribution. Oh, wait. Before we do, notice this is another one of those a, b, 8 square root of x, 8 square root of x. It's repeated. And the 3 root y is repeated again. And even better, one is a plus problem and one is a minus problem. Whenever you have the conjugates, a plus binomial and a minus binomial or subtraction binomial, the middle will cancel out. But I'm not going to skip steps here. We'll see it all play out. We'll just work it out piece by piece. Okay, so I'm going to take the first term times the first term. That's the first part of the FOIL, is to multiply the first terms. Now, 8 is a whole number. 8 is a whole number. I can multiply this and I get 64. Now the square root of x times the square root is x squared, the square root of x squared. That's the first part in the FOIL method. Next, I'm going to take the outside, FOIL. So the O part is outside terms. Now, the square root, 8 square root of x times negative 3 square root of y. I can take the 8 whole number times the 3 whole number and multiply those coefficients, and I get negative 24. Now, I can take a square root of x times the square root of y, and I get a square root of xy. Okay, now we're going to continue with the FOIL method. We're going to go 3. This is the inner multiplication, the I part of FOIL. 3 root y times 8 root x. Positive 3 times positive 8 is positive 24 + positive 24. And the square root times the square root is square root of y times square root of x. Square root of x, y. And then the last part of the FOIL. So all of these you're going to have to do 4 multiplications when you FOIL it out. A positive 3 coefficient times a negative 3 coefficient is a negative 9. And the square root of y times the square root of y is a square root of y squared. Okay, that's the FOIL method. We finished all the FOIL method. We had all these distributions to do. And now we want to go through and simplify what we have. Okay, now this is a square root of x squared, but a second square root cancels a square power. A second root cancels a second power. So this is going to equal, now the 64 is just my coefficient. That part is done, but the square root of x squared is just the regular x. There's no square root answer on that problem because the square root of x squared was a nice outcome. Now, I'm going to save this for later. Minus 24 square root of xy plus 24 square root of xy. And then lastly, minus 9. And then I have another square root. I can simplify the square root of y squared, and that's just the variable y. Okay, now notice in the middle, square root of xy and square root of xy. These are like. They're like radicals. We can combine them. So when we combine them, what do we get? Well, it's like 24 negative, take away 24 bananas and add 24 bananas. They're the like terms, and we've got a positive 24 of them and a negative 24 of them. All of this is going to go to 0. Those make 0. And what's left? What's left is 64x minus 9y, and that's it. That's the final answer. It is the multiplied and simplified answer. And we were able to do that with basically 2 or 3 steps. They look complicated. Now, actually, they are complicated. What I mean by complicated is they have lots of steps, lots of parts. But don't let that overwhelm you. Every little part is a simple little part. So just do one simple thing at a time. And eventually you'll be able to get these simplified. So hopefully that was helpful, but I encourage you to watch the YouTubes to see some more videos, and it'll equip you to get even better at this. But study hard, and remember to bring these notes completed with you on to well, actually you're going to send them to me on Zoom on Monday. Or, man, I'm getting all mixed up here. You're going to take a picture of these notes, email me the picture on Wednesday, this Wednesday before Zoom. Study hard, everybody. Bye-bye.